Hello, Sagar, I am audible. Please confirm.
Yes, sir, audible.
Okay, okay. Screen is visible. First slide.
Yes, sir.
Welcome slide is visible.
Yes, sir.
Okay, okay. Okay, we'll start within 5 minutes. Let us wait for 2 or 3 minutes. Sagar, slide is moving. Slide is moving, Sagar. Okay, now we will start our session. So, welcome all in week 2 hydraulic engineering PMRF live session. Today we'll discuss about the basics of fluid mechanics. In the week 1 also we have discussed about the basics of fluid mechanics. In week 2 we will also discuss about the basics of fluid mechanics. So hope I think you all cover the week 2 videos. So let us first discuss some concept about the pressure, absolute pressure, vacuum pressure, and atmospheric pressure and gauge pressure. So this concept is very important. After that we'll solve some question based on that. I think we have the question based on that we will solve. Please anybody confirm I'm audible, very clear.
Yes, sir.
Yes, sir. Audible.
Okay. And one thing I want to also know, I'm writing something on the screen, it is visible.
Yes, sir.
Okay, now we will start. So here basically I want to give you some concept about the uh, atmospheric pressure, PATM, and the P absolute, and P vacuum. Okay. So as the figure is given, this dashed line, let us suppose the P atmospheric. What is the value of the P atmospheric at the earth surface? Pascal. This is the value, 10, 13, 25 Pascal. So this is the P atmospheric. If the pressure above, if we want to measure the pressure above, if the pressure value is above the P atmospheric, let's suppose your value is 121325 Pascal, your pressure at some instrument, some system, or you can say anywhere. So if you want to find out the gauge pressure here, so what you will do, so P atmospheric minus, that is your not P atmospheric, whatever the P is given here, and minus the P atmospheric. So this will give you the gauge pressure. So you always remember the gauge pressure is what? Gauge pressure is the pressure, whatever the pressure is given, then minus of the atmospheric pressure. And the vacuum pressure is just opposite, the pressure below the atmospheric pressure. So this is the vacuum pressure. If you want to write equation from here, let us suppose here, if you will see this arrow, the absolute pressure is having what? P absolute, ABS. P absolute is what? P atmospheric, from here, from absolute vacuum to atmosphere. P atmosphere plus P gas. So always remember. So P absolute is what? P absolute is the combination of both atmospheric as well as your gas pressure. Okay. So this is the whole idea about this. And what about the vacuum pressure? if the vacuum pressure is nothing but the P vacuum, if anyone want to find out the P vacuum, what you will do, P atmospheric P atmospheric minus whatever your value of the pressure is given, so this will give you the P vacuum. You can visualize from this figure what is the P vacuum. From absolute, from this black line, that is the P absolute 0 line to the above that dashed line is the P atmospheric. If you will minus your absolute pressure, so it will give the your vacuum pressure. So this is the whole idea. So now the question based on that, or the first question, yes, gauge pressure at a point is equal to what? Based on that, please, you have 2 minutes, 3 minutes, 2 or 3 minutes, or just give your answer whether A, B, C, D, which one is correct, or you can write in the chat box also. You can write your answer in the chat box also. The gauge pressure at a point is equal to, first option is absolute pressure plus atmospheric pressure, absolute pressure minus atmospheric pressure, vacuum pressure plus absolute pressure, none of the above. You always remember your vacuum pressure is less than the, your vacuum pressure is always less than the atmospheric pressure. So okay, Sagar, you are telling the option B is correct. Okay. Okay, P means here you are telling about the absolute, right? P absolute, okay. Another one, Ratnasri, what about your, and Bhuvan, we are solving the question number 3. So you can also give your answer in the chat box. Okay, I think he lost the connection. Okay, so option B is correct. Yeah, gauge pressure is always the P absolute minus or P atmospheric. So this is good. Now moving little bit. Okay. Okay, before ahead moving, let us, in the first question, if it is visible, so what is the first question is the, in a static fluid, the pressure at a point, option A equal to the weight of the fluid above, equal to all direction, equal in, not, option B is a equal in all direction, option C is equal in all direction only if its velocity is 0, option D always directed downward. So this is the question, this is a very important question, and this is a very conceptual question. Please write your answer in the chat box. The option, you read the question first, very in the concentrated. So what is the answer? Okay, hydrostatic pressure is same at all point. In the static fluid means what is basically your velocity is zero. In case of a static fluid, the pressure at a point is equal to the weight of the fluid above, equal in all direction, equal in all direction only if its viscosity is zero. Not I think previously I was read about the velocity, not that is the viscosity is zero. Okay, and option D, always directed downwards. Okay, hydrostatic pressure is same at all points. Okay, good. Sagar, and what about your answer, Ratnasri? What is your idea on that question? Sagar is telling the option B is correct. Okay, okay, option B is correct. Good. So why it is correct? Let us discuss on that. As per the Pascal law, in the side I have given the figure. So as per the Pascal law, actually in the static condition at a point, the pressure at a point equal in all direction. So option B is correct for that. Now, okay, here I want to tell something. If let us suppose if water in a bucket, let us suppose water is there and it is not moving, that is velocity is zero. What about viscosity? Viscosity will be zero or not equal to zero. So which one is correct? That is here option I want to put here 1 and 2. And based on that I will give you which one is correct. Please if you want to tell, otherwise you can write also in the comment box which one is correct, whether 1.1. Sagar, you are telling the viscosity is zero. Okay, okay, in the static fluid actually you are, Sagar, you have some lack of properties of the fluid knowledge. Okay, I will discuss, no problem. So actually viscosity is what? Viscosity is a property of fluid basically. If let us suppose here water, that is H2O. If I put here the, let's suppose honey or glycerin, honey, glycerin. So viscosity of water is greater than, viscosity of water is less than the honey, or viscosity of water is less than the glycerin. So actually viscosity is not zero. Here what is zero? The shear stress formula, you know, the as per the Newton's law of viscosity, du by dy. Why here the representing the depth of your bucket. This is why. Okay, so here velocity is zero. If velocity is zero, what is shear stress will be the zero in case of static condition. So viscosity is not zero because viscosity was what represent, viscosity is because viscosity is not related with the static or the movement of the fluid. It is a properties of fluid, but your shear stress is related with the moving of fluid. So always remember, shear stress will be zero, but viscosity not zero. Why shear stress zero? Because of the velocity is zero here. So hope I think clear from my side. Sagar, you got it my point?
Yes, sir.
Yeah, okay, okay, thank you. Now let us move on to another question. Another question number 2. Fluid statistics. The fluid statics deals with what? Viscous and the pressure force, viscous and gravity force, gravity and pressure force, surface tension and gravity force. What? Fluid statics deals with what? Please give your comment. In case of the fluid static condition, Ratnasiri is telling the option A, viscous and the pressure forces. Okay. Sagar is telling the option B is correct. Okay, let me explain in another way. Actually, in case of the static fluid, what you need to calculate, basically in case of a static fluid, you always uh, need to calculate what is the pressure at a point, from at a point this, let's suppose at point P, what is the pressure at, what is the pressure at point Q. So pressure force is very appropriate for this fluid fluid statics. Now whether the viscous force is important or whether the gravity force is important, here is the consideration. So in case of, if the fluid is static, that is your velocity is zero. If velocity is zero, what will happen? There is no shear stress component. Other also, if velocity is zero, not any acceleration things. So what will happen? There is no role of your viscous here, but the gravity force, that is your gravity is very important in this case, because you have calculated here the pressure is what, rho gh, rho gh. How this formula is coming? When you, what you will do when you com compare the weight of the fluid one side and another side is, let's suppose, the pressure force at a point. So these comparison, that is your weight means what, your the gravity of your fluid. So these option C is correct for this question. The gravity and the pressure force is important for that. So hope you will get my point. Now moving on the another question, the question number 4. The center of pressure, the center of pressure of a plane surface immersed in liquid is what? Above the center of gravity of the plane surface, at the center of gravity of the plane surface, below the center of gravity of the plane surface, none of the above. We are talking about here the center of pressure, center of gravity. You know already what these are. So please give your comment on this question. Question number 4. Please write your comment in the chat box for question number 4. So please, your answer is, Sagar, you are telling the option B is correct, right? At the center of gravity. You are telling the option number B, Sagar?
Yes, sir.
Okay, okay. Okay, so we'll, I think Ratnasiri is not here. So what actually center of pressure, actually the plane surface means what here? Actually the plane surface, uh, let us suppose this type of plane surface, some random plane surface you can imagine, or some rectangular also you can imagine. For sake of your understanding or simplicity, the center of pressure of a plane surface immersed in a liquid is what? Let us suppose this is a liquid and one plane surface I have immersed. So what will actually, this is the center of gravity or center of centroid of your body. Now what is your center of pressure is actually, you know the formula of this center of pressure height. The calculation of center of pressure height is what? That is the h bar plus ig ah bar. So this is the formula actually, the center of pressure. So center of pressure is always actually greater than or below the center of gravity or centroid of the surface. So you always remember. So the option C is correct. Below the center of gravity of the plane surface. So always remember, please. This is the important question. If it is immersed on angle, so here sine square theta will be added at the here. So now moving on the another. Okay. So this is also important thing, that is the buoyancy concept. The condition of a stable equilibrium for a floating body is what? The option number, question number 5. Let me read it. For the question number 5, the condition of stable equilibrium for a floating body is, here body is floating on the water, like you just imagine a ship. A ship is floating on the water body. So the option A is what? The metacenter M coincide with the center of gravity. In what condition your body will be stable? This is the question. If body is floating on the water. Option A is what? The metacenter coincide with the center of gravity. Option B, the metacenter M is below the center of gravity. Option C, the metacenter is above the center of gravity. The center of buoyancy B is above the center of gravity. So this is the option. So please write your comment in the chat box. Ratnasiri, you also participate. If you are there, then it will be benefit for you. Here this is not a competitive exam kind of thing. If you will take attempt, it will be benefit for you. Yes, please, Ratnasri and Sagar, you both please write your comment in the chat box.
Sir, option C.
Okay, you are telling the option C is correct. The metacenter is above the center of gravity. Ratnasri is also telling the option C. Okay. Yes, this is correct. Your metacenter will be always in a stable condition above the center of gravity. I have some pictorial representation for that. I will show you. after the question number 6. Okay, question 6. After question number 6, I will show you the pictorial representation. The metacentric height of a floating body is, okay, is it possible to metacenter in case of the submerged body? Please. Sagar and Ratnasri, please just have a interact. Is it possible? Yes or no? You can also write in the chat box whether the metacenter height is possible in case of submerged body, that is the completely sink body. Metacenter height. Please write your yes or no. Just type, or you can also speak.
Sir, it will be negative, sir. Not possible.
Okay. Okay, good. Yeah, definitely. This is the metacenter actually we generally talk about in case of the floating body. Okay, so always you not have confusion. Never you, I think sometimes in the examination this type of question maybe you can see. So you always remember, in case of the, if question is asking about the floating body, then only metacenter height will become in the picture. Otherwise, if it is the static, if your the submerged body, option, maybe the option will be there in the your examination, the whether the metacenter option will be there. But if in the question itself is given the submerged body, so there is no you you can discard this question, this option also. So now the question number 6 is what? The metacentric height of a floating body is the distance between metacenter and center of buoyancy, the distance between center of buoyancy and center of gravity. Option C, the distance between center of metacenter and center of gravity. None of the above. So please write your comment for question number 6. Metacentric height of the floating body is what? So it is the distance between CG, that is the center of gravity, and the center of buoyancy. Okay, Ratnasiri is what telling? Ratnasiri is also telling the option number B is correct. Okay. No, this is the option B for this question. Option B is not correct. Option actually the distance between metacenter and the center of gravity. Now I have picture for you. Let me show you the pictorial representation. So this is about the buoyancy actually. Due to the buoyancy force, you are able to float Okay, here I have some pictorial representation for you. Let us suppose this is the floating body. These are the, here three bodies there. One in the stable condition. This is also stable. This is also stable. And this unstable thing. So in case of, if your body is in static, this is your body. If your body is static, there is no movement of in your body, what will happen? There is no meta center. Even if your body is floating body and there is no movement, there is no actually rotation in your body, so there is no meta center in case of floating body also. Always remember, this is important. Now if you give some rotation, let us suppose some force or some wave is coming in the water and hit here or hit the here, what will happen? Your body will be imbalanced. Your body will be imbalanced. So what will happen here? So from your center of gravity to meta center, this is your the metacentric height. This is your metacentric height. Always remember. So if your center of gravity or if your metacenter height is above the center of gravity, it is the stable condition. Now in case of unstable, if the force from this side will be much, then what will happen? Your body will be overturning moment. What will happen? Your moment will sit below the your center of gravity. In this condition your body will be unstable. So always remember, in case of floating body, if body having some rotation, then metacenter will be occur. If having the more rotation, that is overturning case, it may be in the unstable case. Little bit rotation, it will be the stable case. But how you will quantify how much, that is the is depend on the distance between G and L, that is the center of gravity and the center of, that is your metacenter. In case of submerged body, when your body will be stable, center of buoyancy and the center of gravity, when the center of buoyancy lie above the center of gravity, this is the stable case. In case of your sink body, if naturally stable, when it will be the naturally stable, when your body, your center of buoyancy and the gravity will coincide with to each other. An unstable case, when your center of buoyancy will be below the center of gravity. So always remember. So this is the whole idea. Now here I have one question for you. The absolute pressure and the vacuum chamber. So hope, I think in the previous slide you got it. Please just give your comment on that. You got it, the concept behind the floating body and submerged body? Okay, good. Ratnasri is telling. Okay, good. Now moving ahead on the next. Here is one question. Actually, this is the for this fluid mechanics. Actually, I have followed the Sinjal and Simbala book. So this question from that book. What is actually here telling? Now, a vacuum gas connected to a chamber and read 5.8 psi at a location where the atmospheric pressure is 14.5 psi. Atmospheric pressure will vary from space to from location to location, you know, always because in the your earth's surface is not flat everywhere, somewhere the mountain is there, so your atmospheric pressure will be vary from location to location. So let's suppose at a particular location atmospheric pressure was 14.5 psi. This is a unit of, here the 5.8 determine the absolute pressure in the chamber. Absolute pressure is what? Your absolute pressure is nothing but the pressure, atmospheric pressure minus the, here the vacuum pressure is there, so minus vacuum pressure. So what is actually written in the solution? The gauge pressure of the vacuum chamber is given, the absolute pressure in the chamber to be determined. This is the way of solving actually what the writer want to tell you. Actually before solving the question you always self analyze what is given, what we need to the calculate. So this line is written here. The analysis part is what? The absolute pressure is easily determined by the equation whatever previously I was showing. So here the vacuum pressure if you will remove from the absolute pressure asking, so atmospheric pressure minus vacuum pressure give you the absolute pressure. I will show you the figure. Yes, if you will see here, your atmospheric pressure is given 14.5 something. Your vacuum pressure is given 5.8 something. Here asking about the absolute. Atmospheric minus vacuum give the absolute pressure. Always remember your vacuum pressure below the atmospheric pressure. So now moving. Okay, streamline concept. I think streamline also sir is covered in the week 2. So question 7 what telling? A streamline is a line which is along the path of the particle. This is a very important concept, streamline concept. Always remember, always uh, important in fluid mechanics. So a streamline is a line which is along the path of particle, which is always parallel to the main direction of flow, across which there is no flow, on which tangent drawn at any point give the direction of velocity. So this is the question. Please write your comment in the chat box for question number 7. Very important. You always remember the difference between path line, streamline, straight line. So these are the imaginary line, but it having the importance. Okay, Sagar is telling the option D or A. Okay, maybe D or A, both you are telling. Okay, we will discuss about that. And Ratna is telling the option D is correct. Okay, let me. Actually, the streamline is nothing but let us suppose water is flowing in a pipe, that is a transparent pipe. You can see the glass pipe. You can see that type of pipe. Actually, you can see the water flowing in the pipe. So this is that type of pipe we are considering here. So if water is flowing in the glass pipe, you just take a snapshot at a particular time. You just take the snapshot and you draw the line. Let me write something that we will get more. So here what I was telling, let us suppose you have a transparent pipe and water is flowing in this. Here entering and here leaving the water. At a particular time t, you have taken, suppose you have taken the snapshot of this water flowing. So actually this is a line. Here it is itself, it is written line. So what you will see, the fluid particle, a small fluid particle, you will get, this is the snapshot. Let us suppose this is a snapshot. A small fluid particle is flowing. Okay. So if you will if you will connect the all the particle or draw a line, what will you will see? You will see a line. So this line give you the streamline, and all particle having the velocity. This particle is having velocity, this particle is having velocity. If let us suppose your water is flowing like that, not very straight, if water is flowing like that in the channel, in the your pipe, if water is flowing like that, what will happen? Each and every point, this line is come from where? When you connect the all particle to each other at a particular time, you are taking the snapshot, then what will, at a each particle having velocity. So when you draw a tangent at any point, it will give you velocity. It will give you velocity because it is this line is the locus of the millions of the particle in the flowing flowing fluid or in the pipe. So on which, so basically the streamline concept is this. So on which the tangent draw at any point gives the direction of velocity. So this is the correct option. Along the path of the particle, which is along the path of the particle, this question is given for, actually here you need to select only one option. So you always remember, if condition is there, you need to select only one option. So best appropriate option you always should prefer. This is the actually before you giving any exam, this line is always written. You when you will see the exam, you always prefer the best choice. Now coming on the next question, for liquid, let's suppose water. I am talking about here water. For liquid, will capillary rise increase or decrease with a rise in temperature? This is very important question, because here lots of actually the concepts are there in this question. So please read and correlate with the form. You can physically you correlate how the capillary rise correlate with your surface tension density. Then you comment on this question whether option A, that is increase, whether option B, decrease, remain constant, first decrease then increase. This is a very important question, question number 8. So please, I need your comment on that. For question number 8, this is very important question. Then I will discuss with you concept. Here the surface tension concept will be used, and your density concept will be used, how surface tension and density varies with your temperature, and also how cohesion force and adhesion force responsible for the molecular forces, molecular attraction, that is. So these things, actually this question have the broad concept. You have 3 minutes for that, this question. After 3 minutes I will discuss. I have some pictorial representation for that also, how the densities vary with temperature, how your surface tension vary with temperature. These questions might be confusing, uh, but if you will think, then you can easily possible to give the answer for this question. So after 2 minutes I will discuss about this. Within 2 minutes, please Sagar and Ratnasri, you both write your answer in the chat box based on your understanding. Okay, option C, nice telling, remain constant. Okay, Sagar, you are telling the increases. Okay, okay, let me discuss. You always remember one thing, as your capillary rise formula, if you will see, H is equal to 4 sigma by rho CD. For water I am writing here. Okay, so this is that. So this is what surface tension, and this is the density. Okay, and this is the your diameter of the tube. So let us suppose your diameter will be constant at any temperature. So this is the assumption here I am taking. So what will happen, as increasing, or what is surface, your height is depend on what, surface tension and density. and surface tension and density itself directly related with the, it is directly proportional to, surface tension is directly proportional to your density. After the lots of experiment, we have find out what surface tension. If your any liquid having the density more, let's suppose rho 1 greater than rho 2, that is your honey and water. So here the surface tension in the honey will be more the surface tension water, so directly proportional to. For this formula you might be confused. How you will confuse? uh, Before I will talk the confusing part, then I will go for the conceptual thing. So as temperature rise, actually your surface tension due to cohesion force, or intramolecular interaction between the force. If intramolecular interaction between the your fluid particle more, then cohesion force will be the more. So as cohesion force will be more, what will your surface tension will be more. Density is what? Density is nothing but, density is a how number of particle in a particular volume. Let us suppose if you want to compare the two liquid densities in a particular volume, fixed volume, how much number of particle present. If let us suppose your liquid rho 1, liquid rho 2, if liquid number rho 1 having the more number than the liquid rho 1 2, what will happen? Your rho 1 will be more, because it is the same. Okay, because the same volume here. So this is also depend on the intramolecular. In case of liquid, we are talking about in case of liquid. In case this is also indirectly depend on the your cohesion, because if the cohesion is more, the more number of the fluid particle might be possible to uh, add. We can put here, we can put the more number of particle if the cohesion is more. So if you compare these things, your that is surface tension and density is directly proportional to. If density will increase, your surface tension will increase. If density will decrease, your surface tension will be decrease. So this is the this condition. Now as increasing the temperature, what will happen? The distance between the particle, fluid particle, your liquid particle will be increase. The distance between the particle will be increase. The distance between the particle will increase. If the distance between the particle will increase, what will happen? Your density will be decrease, your surface tension will be decrease. If surface tension will be decrease, your H will also be decrease. So this is the whole concept behind this question. You don't confuse from here. If this is also, if your surface tension is decrease, if your temperature is increase, what will happen? This will be decrease, this will be also decrease. But this is inversely proportional to, what will happen? Inversely proportional to, it means not if this decrease this will be increase, not, because this both the surface tension and your density part is having the relation, directly relation to each other. So here we can compare your the capillary rise or fall with the surface tension. If temperature will increase, in case of fluid we are talking about, in case of liquid, not gas. In case of liquid, what will happen? These things will be happen. The cohesion force will be decreases, surface tension will decrease, also your density will decrease. So what will happen? Your if this is directly proportional to, if this will decrease, this will be decreases. So option B is correct for this question. Hope I think these all conversation you got it. For this I have given here some the explanation about that how the densities varies with temperature. If you will see here, the temperature is rising here 200, 260, 280, 380. The temperature is rising in this direction and density is falling because here 0.94 above you will go 1.2. So this is falling. As temperature is rising, your graph is going down. So the temperature is falling, temperature increasing, your density is falling. Let us suppose if we take this point, what will happen? This is the 310, the temperature is 310 and your density is this much. If you will come here, your temperature is what? Your temperature is 360 but density is 0 point above the 0.97, you can tell. So temperature is 360, here temperature is increasing or density is decreasing. Similarly with this surface tension also. So remember these things. So surface tension actually what physically how can you visualize, physically how can feel. So this is the definition is, it is the property of liquid by virtue, it is a property of liquid, not gas, always remember, liquid by virtue of which it try to minimize the free surface area, it try to minimize the free surface area. And it is happened why it is try to minimize the free surface area? Because of the cohesive force between the liquid molecules. If the cohesive force will be very high between the molecules, what will happen in a small in the less volume, more fluid particle will be we can keep it. So if the cohesive force is more, so this is the idea. If anything having the more cohesive force than the another, then the another, that is the more cohesive force things having the more surface tension, and that thing will have the less surface area, free surface area. You can keep it in the small surface area uh, also comparatively the another one. So this is the whole conversation. And the cohesive force for some student, if not, cohesive force is nothing but it is the attractive force, actually the attractive force between the same type of particle, same type of fluid, same type of substance, you can tell. And the adhesive force, it is the attractive force, it is also, both are the attractive force but different material, not same substance. Like the glass or water, here the water in cohesive force, between the force attraction or force between water molecule to another water molecule. Here the adhesive force, the attractive force between the water molecule, or you can say the glass. So this is the whole idea. That is the reason, due to the adhesive force, the water molecule uh, you can see always in the glass some water molecule are uh, adheres. So this is the adhesive force. Because of the always if you will even if you will completely uh, pour the water from the glass, then due to the attractive force between the, that is the adhesive force, your water molecule will be uh, adheres to the water glass. Now moving on the next, these are the what I was telling. I have kept it for you. When you will download this, or I think you are not able to download, but when you will see PPT in the Google Drive, so for you I have written. Now coming on the, this is also very important question. So atmospheric pressure held in terms of water column. So this is a little bit twisted question but important. The atmospheric pressure held in terms of water column. Option A 7.5, B 8.5, C 9.81, D 10.3. Yes, please give your comment. Hope I think surface tension and adhesive force, cohesive force, and capillary rise with temperature. You both got it. Please give your comment. Okay, okay. Ratna is telling both you are telling the 10.3. Okay, definitely it will be the 10.3. How it will 10.3? Let me discuss. Or we can wait for 1 minute if someone want to try when someone see the video, or I think that time he can pause the video and solve. Let us move ahead. Now here the atmospheric pressure held in term of water column. Atmospheric pressure is what? Atmospheric pressure value is, previously I was tell, the 1 atm is what? 10, 13, 25 Pascal. So in terms of water column is nothing but your pressure equal to, water column means here the density of water, or your height. Column means you want to, anyone want to see this that much pressure in terms of water column. Okay, now here if you will put the 1000, the density of water 1000, 9.81 into h, 10, 13, 25. So what it will give? H is equal to 10.3 meter. So if you will put this is the height of water, height of water means HW. So this is the 10.3. So if you want to see the that much pressure, so what you will do? In the 10.3 meter water column, you need to put the water, and you will, if you will calculate here, if you will calculate here the pressure, this will be equal to this much. Let us suppose you have a tube, and in the tube your tube is 10 meter, 10.3 meter. So at that point, if you will calculate the pressure, this will be equal to what? Rho gh. So rho is 1000, g is 9.81, or h is 10.3. So this will come again 10325 Pascal. So this was the question. Now the question number 10 is what? A submerged body will be unstable equilibrium if. So again we come back on the meta center. But this is the submerged body. Always remember. That time I was telling to both of you, in case of submerged body, what thing we will not consider. Actually, I think here the option is not like that. So what we will do? Okay, please give your comment, then I will tell you. At the point of D, you can also none of the above. at that plate you can take. Okay, in case of submerged body, your body will be unstable, stable, or naturally stable. This is in floating body also stable, non-stable, and uh, things are happen. But here the question is, if body is submerged, what about your answer? The option D, you can say the none of them. Okay, option B you are telling, but okay, give your answer. Okay, okay. Previously I was tell you. Let me go on the another. Yes, here in the case of floating body, in case of the floating body, the meta center point is come in the picture. But in case of the immersed body or the submerged body, okay, maybe okay, okay, okay. Now question, if you will think like that, your submerged means here not completely, partially. I think this question is asking about the partially submerged. So if it is partially case, then what will your meta center, if it is unstable, your meta center will be below the center of gravity. That is option B is correct. Okay. Now moving ahead on the another question. Calculate the capillary fall in a glass tube of 2.5 mm diameter when immersed vertically in mercury. Take the surface tension as 0.52 Newton per meter and the angle of contact 130 degree, 130 degree for water. Okay, please give your comment. Just to calculate this. The solution of this question I have in the next slide. I will show you. First, to take the attempt. Yeah, if it is fully submerged, there is no meta center case. But here is the maybe the partially the question. Okay, move ahead. Question number 11. Please try to solve. I have the solution. I will show you. Okay, let me show you the. Okay, this question is also very important. We will solve and moving ahead in this question. This is also important. So the answer of this question is, you can see here. Your capillary rise formula is this. For the mercury case, your capillary rise formula 4 sigma cos theta rho GD. So 4 is there, and your surface tension was 0.52 and cos 130. Rho ZD, rho is nothing but your rho of mercury is what? 13600 kg per meter cube. So this is, if you will calculate, it will come on 0.004 meter. And why it is minus? Because in case of mercury, if you will see, the capillary rise in the downward, so capillary fall actually downward. So this is the case, and this is the formula, and answer is the 4 centimeter. I think in the above option is not there, so you can, or if you want to take for sake of time, you can take the screenshot of this question. Okay, now moving ahead this question. So the question 12, if you will see the question 12, this figure, we are talking about this figure. Below figure shows a tank of full water. This tank is like that. The width of the tank is 2 meter. The width, if you will see the width, let's suppose this is the width of the tank. So this width is the 2 meter. Width is 2 meter. If we are looking from the front, so that's why we cannot see the width. So width is 2 meter, you remember. So question number 12 and question number 13, just see. And the question 13 is associated with the same figure. This figure I have put it for your understanding. I will tell you during the explanation. Question 13 is in the above problem, that is in this problem, find the weight of water in the tank. Weight of water in the tank. So weight, as well as you need to, in the question number 12, you need to calculate the total pressure, actually total pressure force, because we are looking in the Newton, so that's why total pressure force we need to calculate here. So this is also very important question. Please try to solve. And after that, one question I have, that is a very important based on the Pascal law. Then I will show you the another question, which was the previous year hydraulic engineering question, 2023 hydraulic engineering assignment question, the previous year, that I will show you. So for question number 12 and 13, please, for that question number 12, I will give you the 5 minutes. For question number 12, I will give you the 5 minutes, please. Go through the question number 5. Question number 12. And please write your answer in the chat box. Okay, we'll move on the question. Let me explain. Actually, this question is asking about the pressure force at the bottom, at that level. At that level, what is the pressure force at the bottom? So, before, pressure force is nothing but force is equal to what? Pressure into area. As you know, the pressure is equal to force by area. So, here we can calculate the force is equal to pressure area. So, at that bottom, what will be the pressure? Rho GH. Rho, you know, this is the water. So, 1000 equal to 1000. G is nothing but 9.81, and H is what? H is the total height of the water. The 3 and here the 3.6. That is 3 and here the 0.6, that is the 3.6. And if you will calculate these things, you will get 35316 Pascal. Here, but you need to calculate the force at the bottom. At the bottom means what? What is the area at the bottom? If you will area at the bottom is what? This is nothing but your Newton per meter square. Per meter square, that is the, if this is the 1 meter square, this area is, if the bottom area, this is 1 meter square. In this 1 meter square, your pressure is 35316 Pascal. Your actually itna new, that is the your 35316 Newton acting on this much area. This is the meaning of the pressure, but you need to calculate on the whole area. So what you will do, width is 2 meter, length is 4 meter, so area is how much? 4 into 2, that is 8 meter square. So area is 8 meter square. So 35316 into 8, if you will calculate, you will get the 282528 Newton. So this is the answer of this question. your pressure force is equal to this. Now this is question number 12 is over. Now the question 13 is asking about, in the above problem, find out the water in the tank. Find out the weight of the water in the tank. So for weight, what you will do, just you try. I will give you the 2 minutes for that. Actually, what is the weight formula? If you will go from the very basic, what is the meaning of weight, then you can calculate easily. So please try to attempt the question. I will give you 1 minute, Ratnasri. If you are not able to, then I will explain. Ratnasri, are you trying for this question? Okay. Now I will show you the solution, or will solve the solution. Solve the question. Actually, the question number 13 is asking about the weight of the water in the tank. So weight is nothing but, you know already, weight is mass into acceleration due to gravity, and mass is what? Your rho into volume of the tank. You know already the density is equal to mass by volume because of the kg per meter cube. So kg represent the mass and meter cube represent the volume. So volume of the tank is what? Tank having two parts, that is the width, that is the point 0.4. Two part means what? This column and the below one, 0.43, and width was given already in the question is 2 meter. So first part plus second part, 4 into 0.6 into 2, 4 into 0.6 into 2. If you will calculate volume, 2.4 plus 4.8, what will give you? 2 7.2 meter cube. The volume of the tank is 7 point, and the rho you already know, 1000 into 7.2, that is 7200. Here you will put m is equal to 7200 into 9.81 you can take, or for the simplicity of the calculation you can take the 10 also. So 72000. If you will take the 9.8, So your answer will come on the 7. Little bit, let me calculate your mass is 7200, 7200 into 9.81, 70632 it will come. So this is the whole concept behind it. This figure I was given why, because of the, if you want to calculate, if let's suppose a water tank is there, if you want to calculate the pressure at that point, so this much height you will only consider, not the whole height. If you want to calculate, so this much height you will be consider. Here you can also one thing interpret, if you want to calculate the pressure, there is no meaning of the area how much. If here, if you will see here, we want to calculate the your pressure. So what we have seen in the this question, whether the area of this upper part is very less comparatively this, or the volume of upper part is less comparatively this. There is no effect of volume of water on the pressure, because it's depend on the your density, your gravity, and your height of the water. So always remember. So this type of analytical question you can expect in the your assignment, or also in the examination, gate examination or other examination also. Now coming on the very important concept from the fluid static. So here what I want to explain, in case of fluid static, if a point, whatever the structure, whatever the structure is there, there is no meaning. If point lie in the same parallel line, same horizontal line, and these all point connect with the liquid, same liquid, not another liquid, so your pressure will be same at each and every point, your pressure will be same. Here you can see point A, pressure at A, pressure B, pressure C, pressure D, pressure E, pressure at F, pressure at G, all equal is equal to the pressure atmospheric plus rho gh. That is this height also h, this height also h. There is no dependency on the structure of your uh, body, that is the fluid container. But at the point of h and I, it will be equal, because it is also in the horizon, on the same length, same line, in the horizontal line, but not equal. Why? Because here the water, here the mercury. If the liquid is same, if here the also water, if water also present here, then pH is equal to pi, if there was water, but not the case. Okay. So this is the concept. Now we'll move on the previous year hydraulic engineering assignment 2023 NPTEL hydraulic engineering. Okay. I think let me share. Yeah, is it visible? Ratnasri, yeah, okay, thank you. Go through the first question. The atmospheric pressure at sea level, what is? Atmospheric pressure at sea level. The question number option A 10. Okay, all of the above, because in the previous uh, what we have solved already the 10.3 of the water column and 760. If you will calculate similarly for mercury, you will get the 760. So okay, now moving ahead. This was the first question previous year. Now the second question is, okay, the height of water column equivalent to the pressure of 0.2 megapascal is. Okay, now it is working. So here pressure is giving 0. Why it is not working properly? 0.20, not working properly. Why? Yes, now it is working. 0.20 megapascal. So megapascal is nothing but 0.20 into 10 to the power 6 Pascal. Pascal is nothing but Newton per meter square. So this is the whole conversion. Now in the water column, the previous similarly, I will directly write the 0.20 into 10 to the power 6 is equal to rho of water, that is 1000 into 9.81 into height. So if you will calculate, h is equal to 0.2 into 10 to the power 6 1000 into 9.81. So it will come around, if we consider this is 10 to 10 to the power 4 cancel, so 100 into 0.2, it will become around 20. So option B is correct for that, 20.38. So now moving ahead, Ratnasri, you got it? Whatever I have done the calculation part.
Yes, sir.
Okay, okay, thank you. Now, moving ahead, the next question. Next question is about the question 3. Liquid used in manometer should have low density, high density, low surface tension, high surface tension.
High density, sir.
Yeah, high density, because of you know the concept behind it. Why high density? Okay, no problem. Why high density? Because of uh, if we not take the high density of the liquid in the manometer, then what will happen for measuring the small pressure using the manometer? We need the length of your whatever we have used the pipe for measuring the, that we use the tube for in the manometer, it should be more, the length should be more, so that is why we are using. I think we have the detailed solution is also given. Let me read it. The liquid used in manometer should have a high density so that the height of the column can be reduced. Okay, because of the manometer are used for high pressure measurement, so it is important to make the column height in the practical level. So that is the reason behind it. Now moving ahead on the next question. Question number 4. A water tank contain 1.5 meter deep water. So please, okay, here a water tank is there. Why it is not showing? Okay, a water tank is there and the water depth is 1.5 meter. The pressure exerted by the water per meter length of the tank. Okay, pressure per meter length. So please try to. So this formula only rho gh will be used, but here the asking not in the Newton per meter square, here asking about the per meter length. Just a little bit twist in the question, that is 1000 into 9.81 into 1.5. If you will calculate, yes, your answer should be, if you will calculate, 11.3. So your pressure force is what? Pressure force is nothing but rho g h bar, actually not h. So h bar is nothing but your height by 2, total height by 2. So if you will put, this is the pressure, but here asking about the area. So how much area? Area is what? Height.
H into 1, sir.
Yeah, because of the per unit asking about, so that is why. So similarly here omega is nothing but your omega is indicating the rho z only. So if you will put the rho z h into h by 2, so you will get the rho g h square by 2. In this formula if you will put, you will get the answer 11.03. So this is the whole idea. You always remember the pressure force is not simply your pressure. This is the pressure force is asking about. So the pressure force is the rho g h bar, always remember, into area. Now moving ahead, question number 5. Okay, but how you will be solved? The question number 5 is given, the equation of a streamline passing through the origin. Okay, passing through the origin of flow. Origin of flow means what? Origin means nothing but x is equal to 0 and y is equal to 0. From that point, origin means this. In the equation of a streamline passing through the origin of a flow field, u is equal to this, that is the cos alpha, and v is equal to sin alpha. For a constant alpha is determined as, actually the question is asking about the what is the equation of a streamline. If the condition is given x is equal to 0, y is equal to 0, this condition is come from the this statement, and u is given this and v is given this. Yes, please try to solve this question. Yeah, let me show the answer first. Actually, the equation of the streamline, the equation of a streamline.
Streamline equation dou u by dou x by u equal to dou y by v, sir.
Yes. So if you will put here the value dou x by cos.
Dou x by cos alpha equal to dou y by sin alpha.
Yes, and after the integration you will get the y is equal to, and after putting the boundary condition what here is given, then you will get, let me show you the answer. The first, the equation of a streamline you will put like that, you will get after the integration both side you will get this. Sometimes it is not showing the, yeah, you will get this. For calculating the c you will use the boundary condition what was given, the x is equal to 0 and y is equal to 0, your c is equal to 0. So if c is equal to 0, then only remaining the x sin alpha, y sin alpha. If you will get the y is equal to x tan, you easily calculate y is equal to what, x sin alpha by cos alpha. So sin by cos is tan. Now coming on the next question, question number 6. The uniform body 3 meter long, 2 meter wide and 1 meter deep float in water. Okay, if the depth of immersion is 0.6 meter, then the weight of the body is what? Okay, very important question. If the depth of immersion only, here water is given, that is the rho of H2O 1000 kg per meter cube. So if you will consider the depth of immersion is only 0.6 part. So if it is the 100% body is this, so zero point 0.4 of its volume above and 0.6 of its volume, here I am writing the V is equal to volume, 0.6 immersed in the liquid, that is water, and the volume of the body is given 3 into 2 into 1, that is 6 meter cube. Now you will calculate the weight of the body. So here if you will apply the Archimedes principle, then you can easily calculate. Let me show the answer. Yes. Is it visible? Answer is visible, please.
Yes, sir.
Yeah, volume you know already, the 6 meter cube. Where is the pen? Volume is 6 meter cube. Okay, and volume of water displaced, this is the Archimedes principle, nothing. The volume of water displaced equal to weight of the body in kg. Okay, specified water, we have here taken the water. So how you will calculate these things? Depth of immersion is here telling the actually depth of immersion is 0.6. So immersed volume is how much?
6 meter cube.
No, total volume is 6 meter cube. If you will calculate the
Immersion,
yeah,
immersion 0.6, sir.
yeah, immersion, yes, immersion is the 0.6 of the total volume, right? So total
Yes, sir.
volume is how much? Total volume is 0.6 into total volume is 6. So immersed volume is how much? Immersed volume is, volume of immersed is how much? 3.6, right? So this is, are you getting?
Yes, sir.
Okay. So immersed volume is this much, and it is asking about the weight. So if weight is equal to what? From Archimedes principle, you know the volume, displaced volume is equal to what? Displaced volume is equal to weight of the body divided by a specified weight of the your water. Weight of the water actually here. Weight of H2O. So weight is nothing but weight is the rho z. So here if you want to calculate from the body weight, so your volume of immersed volume into your rho z, it will give the body weight. So immersed volume 3.6, rho 1000, and g is 9.81. So and weight body. So if you will calculate, so 535 into 10 to the power, let me write in the total number, 35316 Newton in kilonewton, 35.316 kilonewton. So you will solve in another way also. Okay, now moving ahead on the next question. Question number 7. Okay, question number 7 is the two-dimensional flow field represented by phi is equal to 2x minus x. Determine the value of the velocity. So here you know the already the formula. The formula is this: u is equal to phi by del x, and v is equal to this. If you will calculate like that, here asking about the velocity. After calculating the both component u and v, you will take the, you will calculate the magnitude. Now moving ahead, question number 8. In steady flow of the compressible fluid through a pipe, then density, area and velocity of the particular section, 2.5 density is given, area is 1 meter square, and the velocity is 3 meter per second. At another section of the density area is 1.5, 1 meter square, what is the velocity at that section? So it is very important, very, that is a continuity equation you will apply only here. So continuity equation is what? If your fluid is incompressible, then rho will be, both side will be equal. So rho 1, rho 2 will be the cancelled out. But here the compressible fluid, so at each section your density is given at both sections, so 2.5, and another question 1.5, another point. So you will calculate here. So you will get the velocity 5 meter per second. Now, streamline, we have already solved this question. Streamline regarding, that is the imaginary line drawn in the fluid in such a way that the tangent at any point give the direction of velocity or motion. So we have already solved. A streamline is, this is also we have solved already. The pressure less than atmospheric pressure, this is also we have solved. Negative pressure, suction pressure, vacuum pressure, all. Question number 12. For a perfect incompressible fluid flowing in continuous stream, the total energy of a particle remain the same while the particle move from one point to another. This statement is called what? Yes, please.
Bernoulli's equation, sir.
Yeah, this is the conservation of the energy. Okay, conservation of energy. For sake of yours, let me give you some another very important thing. In case of the fluid mechanics, actually what we have the three laws. One is the, why it is not working. We have three laws. One, the conservation of mass, conservation of momentum, and the conservation of energy. Okay, conservation is mass is nothing but mass of the flowing fluid will be conserved. Energy means the energy of the flowing fluid will be conserved. But here in case of momentum, momentum is nothing but P is equal to, that is for momentum I am representing the small p, mv, mass into velocity. So in case of fluid flow, the conservation of momentum, when is it possible? When the p will be constant. When the p will constant, then only your momentum will be conserved. But how p will be constant? Your velocity should be constant or mass should be constant. If this is the first case, mass constant, velocity constant, this is the first case. But in case of fluid flow, this conservation of momentum almost actually practically not possible. So what we will do at that place, and it is constant only when the conservation of momentum, when the summation of force will be zero. Summation of force will be zero means what? There is no acceleration. Here the velocity constant means what? Velocity constant means there is no acceleration in the fluid flow. If the acceleration is, for satisfying this criteria, velocity is constant, we need the summation of force of any fluid particle will be zero. There is, if this condition, then your acceleration will be zero. So practically not possible in case of the fluid mechanics. So what we will do, we will go through the another way for the momentum equation, for the conservation of momentum equation. Summation of force is equal to, is the dm, change in momentum with respect to time. We will solve all the momentum problem in the fluid mechanics with this formula. Not we go through the generally with the conservation of momentum. Actually it is uh, not practically possible. So this is the whole concept. I think, hope you will get little bit advanced, but this is important. Okay, thank you from my side for today. We'll meet again on the next uh, Tuesday. So thank you.
Okay, sir. Thank you, sir.
Okay, thank you.